Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have to find the present value of the income C, which is given right here by this equation, over T1 years, and T1 is 10, so over 10 years, and at annual inflation rate given right here, 5%. So 5% means 0.05. Okay, so how do we compute present value? Present value is integration from 0 to T1, the function C of t, e to the power negative RT dt. So that's the expression to compute present value. And now since we have all these functions already given to us, just write everything down. So in this problem, we'll have to evaluate it from 0 to 10, and C of t is 100,000 plus 4,000 t multiplied with e to the power negative 0.05 t dt. So this is the setup to compute present value. But notice that there's so many constants here. Maybe we should simplify it a little bit before we solve this problem. So let's take out a common factor of, say, 4,000. And since it's constant, you can pull it outside the integral. So what will be left here? Will be left 25 because we took out 4,000 and plus t e to the negative 0.05 t dt. Okay. Now this is a definite integral, but you notice that we have a product of two functions that we have to integrate, and therefore we have to use integration by parts. So let's just solve the indefinite integral separately first. So what is the integral of 25 plus t e to the negative 0.05 t dt? Okay, so we'll be applying integration by parts, and therefore we have to choose u and dv. Now notice that since an exponential function can be easily integrated, we can choose this part to be our dv and this linear part to be u. So u is 25 plus t. So compute du. Since 25 is constant, derivative is 0, and t, the derivative is 1. So du is just 1 times dt. And then dv is e to the negative 0.05 t dt. So v will be integral of this. An integral of an exponential function is itself divided by the constant. So it will be e to the negative 0.05 t divided by negative 0.05. So we are using integration by parts, and now we have this entire expression written as u dv. So recall the integration by parts is, this is equal to u v minus integral v du. So now we just plug everything in that we have found here in place of u, v, and du, and then we solve the integral. All right, so let's see. U is 25 plus t. V is this expression, but note that, let's simplify this expression a little bit more. 1 over 0.05, what is it? It's just 20, and there's a negative sign. So this is equal to negative 20 e to the negative -0.05 t. So let's use this simplified form for v. So -20 e to the power -0.05 t. Then minus, you have another integral, v times du. V is again this entire thing, -20 e to the -0.05 t. And du is up here, it's just dt. So that's our setup. Now let's simplify. Here you see there's a -20 and then 25 plus t and the exponential function as the first term. For the second term, you see this negative and this negative makes it a positive. 20, you can take it outside, it's a constant, and then you integrate e to the -0.05 t the same way as before, and it will be to the -0.05 t divided by -0.05, and then plus the constant of integration. All right. So, you know, this is our antiderivative and we have to plug in 0 and 10 to get our present value. But let's try to simplify this expression a little bit more. Okay, so let's keep the first term as it is. And then in the second term, you see, and again we have a 1 over 0.05, which is 20, times 20 is 400, and there is a negative sign. So this will be -400 e to the -0.05 t. And finally, let's take out the common factor of, let's see, let's take out the common factor of -20 and the exponential function. And we'll be left with, from the first expression, it will be 25 plus t. Now from the second expression, we took out the negative, we took out 120, so there will be another 20. Let's make sure we have everything correct. So this times 25 plus t, and this times 20. And that is equal to first part remains as it is, 20 e to the -0.05 t with a negative sign, and inside you have 25 plus 20, that's 45 plus t. Okay, this is our simplified form of the antiderivative. Now, let's come back to our present value equation right here. And let's evaluate this integral now. This is a definite integral. Now, notice we have a 4,000. And then this antiderivative for this integral is right here. So we will have -20. It's a constant, so we can just keep it by itself. And then the remaining portion that has the variable t, that you can plug in the limits to 0 to 10. All right. Leave this as it is, plug in 10 for t, then plug in 0 for t and subtract them. So you have e to the power -0.05 times 10 times 45 plus 10, and then minus, then you plug in 0. So e to the power -0.05 times 0 times 45 plus 0. Okay, so let's simplify this now. And here, let's see, 4,000 times negative 20. So we have a negative sign, and 20 times 4,000, that will be 80,000. Okay, now inside the bracket, notice this exponential portion, it will be 0.05 times 10, so it's negative 0.5, and here we have 55, minus, in this exponent, we're multiplying by 0, so this is e to the 0, and e to the 0 is 1, so we'll be just left with 45. All right, now let's figure out what is the approximate value, and that will be our present value. So pick a calculator and plug in this last expression. Ignore the negative sign and just plug in 80,000 times 55 e to the negative 0.5 minus 45 and enter. And you see that's a negative value, and we ignored this negative sign, remember, so the two negatives makes it a positive, and it should be positive. So we get an approximate value, and remember this is the present value, it's in dollar, and the value is 931265.1. So this is the present value of this income at this rate over 10 years. Thank you.